This section is Arithmetic Series. A series looks like this. A series is the sum of a sequence. This question, tell if it's a sequence or a series. This right here is a series. A series, again, is when you're adding up terms of a sequence. This right here is called a sequence. A sequence is just a set or a pattern of numbers. A series is a sum of a pattern of numbers. So this one right here is a series because it is a sum of a pattern of numbers. Now the second part of the question says, is it infinite or finite? This is the sign for infinite, you guys. Infinity. Finite means terminates, ends. So this series, does this series stop? Does it terminate? Or does it go on forever? This one terminates. This is called a finite series. It's a finite, and it's a finite series. It's an ending series. This sequence, is this sequence infinite or finite? This dot 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 means it goes on forever. So this is infinite. Infinite. And the last one, dot dot dot, means you're going to add up numbers forever. This is called infinite. Anytime you have dot dot dots, it means it goes on forever. Anytime there are no dot dot dots, it basically is meaning it stops. We're adding up a certain amount of things. Now, could I do this? Could you add up this pattern forever? Wouldn't that just be infinity? Because if you're adding an infinite amount of numbers infinitely, I mean, that's just dumb. It just goes on forever. I could find my pattern. I could find terms in the sequence, but the sequence goes on for infinity. Could I add up these four numbers? Yeah. Finite things you can add up. Number 4, write the related series for this sequence. This is a sequence. It's a pattern of numbers. Now, to write the series, basically, all it's saying is, it's just stupid. You're just going to go, okay, that means the first term plus the second term plus the third term plus the fourth term. Woo, that's all you do. I'm done. That is writing this as this sequence is written now as a series. Now, some of you could sit here and add these up real quick. Evaluate the series. Yeah, you could just add them up and get the number pretty quick. We could do that. But I want to use this formula up here. This formula up here, what this formula is saying, N stands for which term or the number of terms. Two different ways. It also could be, instead of which term, it could be number of terms. You might want to put that as well. It could be number of terms, either one. A1 is your first term. AN is your last term. Because N stands for which term, so you're going to the last term, so N is the last piece. Anywho, so what you do here, for this S, N, means if I want to sum the first blank numbers, what you do is you take the first term and the last term, add them together. You then take the number of terms and half it, and multiply the two. So if I want to find S, how many terms are there? 4. I'm going to do S4, meaning the sum of these 4 terms. Well, what you do is you take the number of terms, which isn't the number of terms, isn't N 4? Half it. And then what's my first term? Isn't my first term negative 12? Isn't my last term 18? This is A1. This is AN, the last term. So what this would be is, what? S4, the sum of the first 4, that's 2. And this right here is 6. So 2 times 6 is 12. So the sum of these 4 terms is 12. The sum of these two, isn't that 6? Aren't the sum of these two 6? These are 6, these are 6. 6 plus 6 is 12. Two different ways to do it. What's interesting about all arithmetic series is if you take the edge terms, the first and the last, and then you take the two next to that and keep going, they're always add up to the same thing. It's pretty cool like that.